Hi guys, today I'm gonna be working on riftCTF 2020. It's a reversing challenge called Real World Web Crack Me or something like that. Anyway, we have a few files here and I've already changed a few of them, so you can I'll provide a link in the description to the challenge files. They actually uploaded their files on GitHub because their CTF platform was not working. Anyway, so in the beginning when I saw the challenge, there were a few things that were basically intended to slow you down. So for example, there was this confetti thing, snow falling. I went in and checked the script. It was nothing, just design related, so I commented this out. Then you also do not need the font here. This actually extracts the font from the internet, so this is not required. And you also do not need the CSS, I think. Yeah, you don't need the CSS either. But you do need a script that they actually originally called the script crackme.js. So this script was originally crackme.js, and it was essentially a string, a base64 string, which was converted into alphanumeric and then evaluated. So what I did was I just decoded the base64 string, and I got this thing which I called crackme deobfuscated 1. So this is still, as you can see, pretty obfuscated. So then I went to an online JS beautifier, and then I essentially got crackme deobfuscated 2. So this just put everything into nice indentation, but still you can't really understand anything. So the JavaScript was one of the issues. The other issue was that if you did change the JavaScript, it somehow detected that you had changed it, and then it didn't run. So you had to use the obfuscated 1 script in the real world if you want to do a dynamic analysis, but you could use this one for a static analysis. But anyway, we have the pretty print in developer tools, so we could use that as well. But okay, let's go back to what the website actually does. I haven't yet shown the website. So the website is this thing. This was originally called crackme.html. So anyway, if you open this website up in a browser, okay, it's still reading fonts dot something. Why is it still reading that? There is zero connection between this and fonts. I guess it shouldn't read. Let's try opening it. Why does it read the fonts thing? Oh, because there's canvas ID snow. Maybe something related to that. Let's remove that as well. So essentially what I'm trying to remove everything except from the bare bones functionality, because it drastically slows things down. What else is left? Anyway, I guess it's okay now. So I'll show you what the functionality of the website is. So you type something, there's no text box. JavaScript directly takes things out of your keystrokes using some key listeners, and then you hit enter and it says wrong password. So you have to essentially type the right password, something going on these lines, and it'll eventually say correct password. Okay, anyway, the second issue was, even after obfuscating the script, we had an anti-debugger in place. So as soon as you hit Control Shift I to look into the scripts, it didn't open because there was an anti-debugger, and then it went into an infinite loop of sorts. So how did I overcome this? So the thing that you're seeing right now, you wouldn't be able to see it if you don't have an anti-debugger. So what I did was I used something called Grease Monkey, which is here, and I used a script called anti-debugger. So I'll put the link to the website that I used to install this as well in the description. Anyway, so once you have this, you can essentially go through the code, pretty print it. Now you don't even need to use the deobfuscated 2 script, because you can see everything over here, and you can do dynamic analysis with this nicely formatted script. Anyway, moving on, how do we see where is the actual function happening? So where is the actual check happening? You can see that there's something called wrong password that's being displayed. So the first thing that I did was I checked where is wrong password. Wrong password is here, but it's nowhere else. You can't check it that way. So that was one issue that I was facing. I wasn't able to see where things were because you can't directly go there because of this obfuscation, right? So I just scrolled through the code. I just tried to see if there's anything interesting, and after scrolling for a while I came across this check function, and it looked kind of familiar. So this breakpoint I put before, it apparently hasn't been removed yet. But anyway, so I could see that there was some things like car code at, and so it just looked suspicious. And then towards the end I saw something interesting, which was that again another breakpoint which I put when I was dynamically analyzing. Yeah, towards the end I saw this. So there was a statement which was essentially checking if the first character was I, the second character was, sorry, the first was R, second was I, third was F, and so on. riftCTF, as you can see. So this is what made me realize, okay, this is the function that we want. So I haven't ever done this kind of JavaScript deobfuscation, but if you're confused about anything, you can essentially just go into the console and check what the particular thing evaluates to. So for example, I wasn't aware of what this means, so I just went into the console, and you can see that it means false. So you can see that the first 8 or so characters need to be riftCTF, otherwise it returns false, and so on. So then you can see that the 29th should be M, 30th should be E, 32nd should be X, and so on. So all of these things, there were some easier parts and there were some difficult parts as well. So there were some places where you had to use a loop. So there was this loop that we had, and we had to, there were certain things that were assigned according to that. So they're saying, okay, go through this entire loop, there's some weird stuff happening here, and after that is finished, the char code at 26 should be equal to this thing, otherwise it will return false. So for these kind of things, what I did was I just copied this code, and as you can see, I made a file called log for some reason. I'm actually gonna name it loop, but I misspelled, and then I just cleaned it up. So this is the exact code which is over here, this or something related to this. There were 2 of these. So wait, I think it's log 2. So this is the exact code that was there. I think it was either this or something else. But anyway, so once you make this file, you can essentially go into log 2. So after I made this file, I just put an alert. So the value that should be equal should be this thing, right? Because we want this value to be equal to the char code. We want this value to be equal to the char code. So I said, okay, alert me this value. So after I made this file, I just ran it and it alerted me 114. So I just found out what 114 means, and I found out what it means in terms of ASCII, right? So if you go into Python and you say char of 114, it says R, right? So that means that the 27th character, because zero indexing, 27th character should be R. So there was another loop of this kind somewhere else as well, like over here, right? This was log 1. So if I open it up over here only, log, oh sorry, I already ran log 1, or was it log 2? Yeah, again R, another R. So these loops I conquered through that, and then there was some easier things like, okay, the char code at a certain position should be one more than the one at some other position. So how do I know that this means char code? You just simply go into this thing, whatever you can't understand, just take that, copy it, and place it into this thing in the console, and you'll see that it says char code at. So you can understand what it means, and after a while you start to detect patterns, so you don't even need to go into the console. But essentially, yeah, this is mostly it. So for example, this thing I remember, it was the word called first, right? So the char code at 17, so I'll show you the flag that I got in the end. So in notes.txt, so we can see here, yeah, first, right? So this was supposed to be R according to the loop, right? And then the one immediately after it, that is 18, should be 1 added to it. So R plus 1 is S, right? And the one after, 2 places after it, should be 2 more than it. So this 19th one is T, because R plus 2 is T, and so on. So there were certain things which weren't conclusive. So if you come across those things, like for example, there were certain things which had a lot of solutions, like XORs and all. So you could simply skip those things and eventually you'd come to a solution anyway. So the things that don't, yeah, like this. So this particular statement was pretty frustrating at first, but then I skipped it, and later on I got the characters anyway. So there were a lot of XORs, and there could have been a lot of solutions to this, but I simply skipped this. Do the easier ones, like the ones that directly ask you to, you know, look at an ASCII value or a shift in the ASCII value. So that's essentially it. So essentially the steps that I followed were, I first deobfuscated, then removed the anti-debugger, then I did a dynamic analysis, slowly going through things, and then whatever things I didn't understand, I put them in the console. At first I started making notes, but then, because I was really confused, but then when I started understanding stuff, then I essentially just went through without really doing stuff. So like here, there should be an underscore at 14. This is what I understood from that statement, right? If there is not, then it'll return false. And then there was other stuff like, you know, as you can see, there's a lot of weird stuff, but all this is doing is, all of these conditions were evaluating to the same things. The char code at this thing should be divisible by 5, and the char code at this minus the char code at something else should be 2, and then this should be whatever. But all of these statements return the same thing, right? And you could simply just look at this last statement and figure out what it means. So I'll show you what I mean by that. So you can essentially go here and evaluate it. It'll give you 125, which is this thing. So that's what obfuscation is. You get stuck on things that aren't really useful. So as you can see, 125 is divisible by 5, but you don't need to look at it. You just needed to look at the last condition. So anyway, that's it for now, and finally, like I said, we got the flag as this thing, get first web crack me exo. So thanks for watching. I know this video wasn't really straightforward, but this was a big challenge, and I don't think I can go through every single thing because there's a lot of code over here. But essentially you have to find the function which does this, remove the anti-debugging thing, and just start putting breakpoints and see how things work out. Another interesting thing is you don't actually have to type in the password. So when you go into the function, where is the check function? Yeah, you see that this is the string that we're checking, so you don't have to type in the entire flag again and again. You can simply copy this, paste it here, and say this is equal to something like riftCTF, right? So then if you put a breakpoint over here and then you run it, oh wait, for a breakpoint you need to first hit enter. Then if you go ahead, you'll see that this means F for some reason. Why does this mean F? I don't know. Okay, I haven't entered the entire thing. The thing is, this actually evaluates whether this is one of the first conditions. Yeah, whether there's an underscore at a certain position. Yeah, my string isn't that long yet. I'll just copy the actual flag. So if you have the actual flag over here, it might just work. Yeah, the interesting thing is you can actually do it while you're debugging, like even when you're at that particular breakpoint. So this is my first time debugging a JS file. It's actually pretty interesting. So you can see over here, it's checking if a certain thing is same as a certain thing's, you know, base 64 conversion, and then you can step over things. So since this turned out to be true, that is, there must have been an underscore at a particular place, we didn't return false. So this turned out to be true. Then you go through this particular thing, you see that the last thing should be a bracket or something like that, I think. Right, so if you don't know what it means, you just look at it and you put it in the console. And this should also evaluate to true since this is the correct flag, right? And then you don't know what this particular character is, so you put it here. This is a dash, right? So they're saying that the 8th character should be a dash and it should be equal to this character over here, which is also a dash. So you see all these 4 characters are dashes. That is because of this code over here. So the 8th character should be the 35th character, the 9th should be the 34th, and the 9th should be a dash, and 34th should be 35th. So all 8, 9, 34, 35 are dashes, and so on. So there's a lot of stuff here. If you have any issues, any doubts, you can contact me, but otherwise I've already laid out the key points. Thanks for watching this video. I felt this was the most interesting challenge in this CTF, so that's why I thought I should share this. But anyways, thanks for watching and bye. See you next time.